Hello friends, let's create a normal histogram, and for that we'll create a new file named normal histogram.py. And once this file is being created, we'll just copy this particular code which is present over there with small changes, which will be the new functions which is added. For creating a normal histogram, we need to call a function named df inverse normal CDF. This is a functionality for calling up the values inside it as p, mu equals 0, sigma equals 1, and tolerance equals 0.00001. Now after this, the next important thing is to analyze if mu not equal to 0 or sigma not equal to 1. In that scenario, return a value, that is return mu plus sigma into inverse normal CDF as p, tolerance equals tolerance. Then we will return these values with the indexes as low of z and low of p equals minus 10.0 and 0. And after that we have high of z, high of p equals 10.0 plus 1. And then we have a value represented like while high of z minus low of z is greater than tolerance, then we need to keep a value as mid of z equals low of z plus high of z, which will be divided by 2. Then we have the next value, that is mid of p equals normal CDF with a value of mid of z. Normal CDF is the other function for the curve, or we can say the graph, which is being developed with the normal distribution curve. So that we'll do now. After this, we'll call for if mid of p is less than p. In that scenario, we'll be doing low of z and low of p with a value of mid of z, mid of p. And the next issue will be elif mid of p, which is greater than p, and then the value is high of z, high of p equals mid of z, and this value will be manipulated, mid of z and mid of p. Now later these values will be manipulated here in else, that is else the value will be break. After this, we need to return these values so that it will be given inside a function, that is return mid of z. So once this is calculated as per the logic of the if statement, so this was my if statement and this was the elif values in it. So elif will be taken over here with these connections. So everything is being done properly. So now we need to call for the normal CDF function. The normal CDF function is df normal CDF as x, mu equals 0 with sigma equals 1, and then with the value that is return 1 plus math dot erf with a value of x minus mu, and it will be divided by math dot square root of 2 divided by, and it will be solely divided by sigma, and the sigma value or whatever the square root value which has been calculated, it will be divided by over here divided by 2. So my function is being created Now this section I'll just put a comment over here where I'm calculating the uniform values and the normal values. So let's get started. Now after this, the next important thing which is needed is to get the seed value done in the uniform way. So uniform is being calculated over here. The next thing is so we have commented that part. In the same way, we'll calculate the normal, which equals a value that is 57 into inverse normal CDF, inverse normal. And then after that, the next value which comes into picture is to set up a random value, that is random values. And this would be set in the normal range. So the normal range is being specified, and that specification is done over here as for in range of the value as 10,000. So the range is being given properly over here. We'll complete this part over here and the normal range value. So this gives the inverse normal CDF being complicated in the reason or being compiled over here in the specific value. Now we need to plot the histogram. So let's get started with plotting histogram, and here the histogram plotted would be the normal histogram, that is plot histogram and the value as normal, comma 10. The comment will be normal histogram. So once this part has been done, now let's go to the code base and now we will compile the code. Let's compile the code as Python normal histogram.py. This will compute the complete logic related to normal histogram.py, and I have removed the commented part over here because it will print both the uniform and the normal histogram. This was the uniform histogram, and on closing this I'm getting the normal histogram. So this way we can analyze with the one-dimensional data which is present in the histogram section. So basically one-dimensional data is nothing but the one which manipulates the value with the one-dimensional data analysis. So this is very important to be taken into consideration. The next chapter is about analyzing the two dimensions of the data and how two-dimensional data can be computed, and how the histogram will be used to scatter it with the different joint distributions.